Modern science generally views the universe as a vast collection of purely physical processes. It is a system of atoms and particles governed by measurable laws. But this creates a persistent gap. If we are made exclusively of physical matter, why do those physical processes feel like anything from the inside? Christof Koch has spent a career investigating that gap. A veteran neuroscientist, he ran a major portion of the brain mapping effort at the Allen Institute. This search requires analyzing the brain's physical structure at immense scales, tracing complex neural pathways exactly like those shown here. Yet, despite decades of mapping the architecture of the brain, science still cannot explain how matter actually participates in the creation of a mind. In April 2026, researchers gathered in Porto, Portugal, for the Behind and Beyond the Brain Symposium. There, Koch suggested that our inability to solve this problem is itself a finding. He argued that if we cannot find where consciousness is made, we may be aiming at the wrong target entirely. His admission suggests that the field of neuroscience may need to invert its core assumptions. Koch's reframing is specific. Consciousness might be less like a thought and more like gravity, a basic feature of how reality is structured from the outset. To support this, he leans on integrated information theory, or IIT. IIT relies on a central measure called phi. It quantifies how much information in a system is integrated beyond what its individual parts could produce separately. On this view, a high phi value marks the presence of experience within a physical system. If the theory holds, consciousness shifts from a philosophical mystery toward a measurable physical property. However, IIT is not a consensus. In 2023, dozens of researchers signed a public letter labeling the theory as pseudoscience. Critics point to a structural flaw. The math can assign a positive phi score to systems with no plausible experience, such as simple circuits or inert grids. A theory that explains everything indiscriminately risks explaining very little precisely. Because falsifiability is the standard of neuroscience, Koch's claim remains a provocative stance awaiting confirmation, rather than a proven fact. The observer-dependent theory of everything, or ODTOE, was built on a related premise, though it arrives there through a different mathematical route. In this architecture, the origin of the observer is treated as a structural feature of the theory, present at the ground floor of its construction. This theory uses a hierarchy of observation to model consciousness as a recursively self-similar structure. This structure spans across scales, from the smallest coherence-bearing units, like cellular microtubules, up to collective fields. These two frameworks suggest a shared suspicion that observation may be a constitutive part of physics rather than a late-arriving byproduct. Within ODTOE, each level of the hierarchy is connected by a specific fixed-point equation. This is a parallel formal intuition, a structural echo developed independently that arrives at a place similar to Koch's idea of integration. This doesn't mean the hard problem is solved, nor that IIT has been vindicated. Observational, steady. Instead, it confirms that the question of where consciousness sits in the structure of reality is wide open and increasingly worth approaching from more than one direction at once.